Hello, good day viewers. Let us find a solution to this exponential trigonometric equation. The equation is a to 1 to the power of sine squared x plus a to 1 raised to the power of cosine squared x equal to 30. And we are looking for the values of x that can satisfy this equation. So let's get started. First of all, you should remember that 3 to the power of 4 is the same thing as a to 1. So let us reduce the bases. So we have 3 to the power of 4, which is a to 1, but we have another power, sine squared x, plus 3 to the power of 4 cosine squared x. This is equal to 30. All right. Secondly, you should know that you can write sine squared x in terms of cosine squared x and vice versa, because sine squared x plus cosine squared x is equal to 1. Therefore, we can write cosine squared x as what? 1 minus sine squared x. So instead of cosine squared x, we are going to replace it with 1 minus sine squared x. Therefore, our equation becomes 3 raised to the power of 4 sine squared x plus 3 raised to the power of 4 multiplied by 1 minus sine squared x. The whole of this equal to 30. Now let us distribute this exponent. We have 3 to the power of 4 sine squared x plus 3 to the power of 4 times 1 is 4 minus 4 times sine squared x. The whole of this equal to 30. According to one of the laws of indices, we can break this down, right? And how can we do that? We have 3 to the power of 4 sine squared x plus 3 to the power of 4 divided by 3 to the power of 4 sine what? Squared x. All of this equal to 30. Now we're going to do a kind of substitution here by letting 3 to the power of 4 sine squared x to be equal to a certain variable. Let's use p. So wherever we have 3 to the power of 4 sine squared x, we are going to replace it with p. So to the left hand side, we have p plus 3 to the power of 4, which is a to 1, divided by p, and this is equal to 30. Now let us multiply every single term by p just to clear the fraction. P times p is p squared plus a to 1 divided by p times p is a to 1. This is equal to 30 times p, which is 30p. Now let us bring 30p inside. We have p squared. As 30p crosses over, it becomes negative 30p, then plus 81. This is equal to 0. Now we have a quadratic equation in terms of p, which we can factorize. Now let us think of two numbers, which when we multiply them together, we have positive 81. And when we add them together, we have negative 30. And the numbers are negative 3 and negative 27. So we have negative 3, negative 27. The whole of this equal to 0. By setting each factor to be equal to 0, we have p either equal to 3 or p equal to positive 27. But remember the value of p, we substituted that with 3 to the power of 4 sine squared x. So recall that p is equal to 3 to the power of 4 sine squared x. So we are going to substitute it back into these two equations. Let me start with the first one. We have 3 to the power of 4 sine squared x equal to 3, right? And 3 can be raised to the power of 1. Since the bases are the same, we can equate the exponents. We have 4 sine squared x to be equal to 1. Divide both sides by 4. Sine squared x is equal to 1 divided by 4. Take the square root of both sides. By taking the square root of the left hand side, you will be left with sin x, and this is equal to plus or minus the square root of 1 divided by 4. Sin x is equal to plus or minus square root of 1 is 1, square root of 4 is 2. So now let us go back to other equation. We have the second one, which is p equal to 27. So we have 3 to the power of 4 sin squared x to be equal to 27, and 27 is the same thing as 3 to the power of 3. So this is 3 to the power of 4 sin squared x equal to 3 to the power of 3. The bases are the same, therefore the exponents are also equal. 4 sin squared x equal to 3. Divide both sides by 4. Sin squared x is equal to 3 divided by 4. Take the square root of both sides. You have sin x equal to plus or minus the square root of what? 3 divided by 4. Finally, sin x is equal to plus or minus square root of 3 divided by square root of 4, which is 2. So now we have these two equations that we need to solve for x in each equation. Let's start with the first one here. Sine of what angle is equal to plus or minus 1 divided by 2? Let's start with the first one. Sine x equal to 1 over 2 before we come back to negative 1 divided by 2. You should know that sine is positive in the first and the second quadrant. I think let me draw this one. If we have a unit cycle like this, we know that sine of 30 degrees, which is somewhere here, 30 degrees, or you can call it what? Pi divided by 6. Sine of pi divided by 6 will give us 1 over 2. That is in the first quadrant. And if you move to the second quadrant, you're going to get another angle right here. Remember that this is going to be 30 degrees, or pi divided by 6 as well. But what is this angle from the standard position down to this terminal point? They will have the same sine ratio, definitely. And you know that this is pi, where this is 2 pi. If you subtract pi divided by 6 from pi, you're going to obtain this bigger angle, which is 5 pi divided by 6. So in each case, we are going to obtain these two angles as our solutions. So let me write them here. X will be equal to pi divided by 6, or x equal to 5 pi divided by 6. I remember to add multiples of 2 pi, because in every complete cycle you're going to obtain a repetition of these coterminal angles. Plus 2 pi k, for which k here is an integer. So what of sine x equal to negative 1 divided by 2? That is in the third and the fourth quadrants, right? So when we have sine x equal to negative 1 divided by 2, the question is sine of what angle will be negative 1 divided by 2? So let me draw a unit cycle again. Suppose we have a unit cycle like this. Remember that we have seen that pi divided by 6, sine of pi divided by 6 is positive 1 over 2, right? So we can get negative 1 divided by 2 right here, right? And another one right here. So let me start with this one. If you look at this one, this line is a diameter. So by adding 180 from this position, it will take you to this terminal point. So let's add 180, and 180, remember, is pi. And if you add pi, you're going to get 7 pi divided by 6. So this is 7 pi divided by 6. So what about this angle? We can get this angle by subtracting pi divided by 6 from 2 pi. And that will give us 11 pi divided by 6. So this is 11 pi divided by 6. So we have obtained two solutions for that negative 1 divided by 2. 7 pi divided by 6 and 11 pi divided by 6. So x here will be equal to 7 pi divided by 6, or 11 pi divided by 6. Don't forget to add 2 pi k, 2 pi k. So now we have obtained 4 solutions for the first equation, which has plus or minus 1 divided by 2. Now let us go back to the other equation. Here we have sine x equal to plus or minus root 3 divided by 2. Let's start with sine x equal to the positive root 3 divided by 2. From the unit cycle, we know that sine of 60 degrees is the same thing as root 3 divided by 2. Or sine of what? Pi divided by 3, because pi divided by 3 is the same thing as 60 degrees. So let's go to the unit cycle. So if this is 60 degrees, which is pi divided by 3, we can get another solution right here by subtracting pi divided by 3 from 180, which is pi, right? So pi minus pi divided by 3, which is going to give us 2 pi divided by 3, right? So this is 2 pi divided by 3. So now we have obtained 2 solutions for that. X is equal to pi divided by 3 plus multiples of 2 pi. Then the other one, 2 pi divided by 3 plus 2 pi k. What about when we have sine x to be equal to the negative root 3 divided by 2? And that can be obtained in the third and the fourth quadrant, right? So let's use the reference angle. This is going to be our reference angle. From that position down here, we are going to obtain another angle. And we are going to obtain also another one right here. So let's start with this one. We can obtain that by adding 180 to this angle, because this is a diameter, right? So 180 is pi, then we add it to pi divided by 3. This is going to give us 4 pi divided by 3. So this is 4 pi divided by 3, one solution. And how can we get this one? By subtracting this angle from 360, which is 2 pi, minus pi divided by 3. This is going to give us 3 times 2 is 6 minus 1 is 5. So this is 5 pi divided by 3. So we have 4 pi divided by 3 and 5 pi divided by 3. So x could either be equal to 4 pi divided by 3 plus multiples of 2 pi. And the other one, x equal to 5 pi divided by 3 plus multiples of 2 pi. And hence, we have gotten so far 8 solutions. You can see them. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 solutions for this equation. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.